So the two duality examples we've done so far haven't really shown you how this will be tested on an exam, because frankly, you could just, especially with the calculator, do both the confidence interval and the hypothesis test and say what your decision would have been or whether it would be inside or outside. You aren't forced to think about and know this relationship. You could actually just go ahead and brute force it or look. So this page has all the ways that I could test this, where you really can't use your calculator to do the work for you, and you have to know and understand this relationship. So the first one is a little bit tricky, but it's fun. It says you collect data and test the hypotheses. By the way, animals here. Yes. And you're testing this. P is equal to 0.5, basically kind of like our fair coin or our helper hinderer examples, or it doesn't equal 0.5. And we're looking for, and we found a 95% confidence interval. So the first question says, would you reject or fail to reject the null hypothesis? Now we don't have an X and an N, so we can't even use the calculator shortcut, but we can look and see if we want to say, could P be 0.5? Well, no, because we think with 95% confidence that P is between 0.51 and 0.56. So we would reject the null. You can also see this because this is outside our interval, right? So if you just sort of have that outside equals reject the null written on your card, you'd also get there. Now the second question is where this takes a weird turn. It says, what can we say about the p-value for the hypothesis test? Since we rejected the null, we know that the p-value must have been less than our alpha. And we actually know a little bit about our alpha, right? If we have a 95% confidence level, the corresponding alpha for that is just its complement, since we're dealing with a two-tailed test, of 5%. Okay, now here's where it gets a little more interesting. Would you reject the null hypothesis at an alpha of 0.1? What I'd like you to do now is take a moment, pause the video, and try to do C and D on your own. Because if you can do them on your own, then it's really straightforward and you'll understand the reasoning. But describing and why this is the case, students always get a little confused by. So if you're back from trying this on your own, would you reject at an alpha of 0.1? The answer is yes. Now why? Those of you who did this on your own, hopefully you have a nice good reason for it. But we know our p-value is already less than 0.05. So it is definitely less than 0.1, right? 0.1 makes it easier to reject the null than 0.05. So we definitely are still going to reject the null. It is still less because we've just made our alpha level, our significance level, less strict. You don't have to be nearly as unusual to have this work out. If you wanted a visual representation of this instead of the inequalities, you could kind of draw up p-values are probabilities, so they could be anywhere between 0 and 1, though as we've talked about before, especially with a single-tailed test, being anything greater than 0.5 doesn't really make sense. But we know that our p-value, ignore the scale of this, I know this is not technically correct. Since we rejected the null, our p-value falls somewhere in this range, right? And now we want to know, how does it compare to 0.1? And no matter what, like I said, it's less than. So again, this is just a visual representation of the inequalities above. Now, would you reject at an alpha of 0.01? Here's where this gets a little bit funky. We know our p-value is less than 0.05, but we really don't know how it compares to 0.01. 0.01 is somewhere here in the range of possible p-values. So if we're here, we would reject the null. But if we're in this section, we'd fail to reject the null. So we really can't say whether or not we'd reject the null. We would need more information to this. So I'm just going to say, I don't know. Really lazy. I don't know. There is no way to know. Need more information, right? This is the only time on a test that we don't have enough information to answer the question would actually be correct. Most of the time, that's just a sucker's choice. But this is one time where it would actually be the correct answer.